Zeal Education Society, redefining excellence.
Hello, good morning to everyone and welcome to Basic Electrical Engineering lecture. Myself, Dr. Mahadev Unde, Professor in Electrical Engineering, Zeal College of Engineering and Research, Pune. In this video lecture, we are going to learn the superposition theorem. The superposition theorem is used for finding the current in a power system. So let us start the statement of the superposition theorem. Superposition theorem ST statement. In a linear bilateral active network having more than one source of EMF current flowing through any branch is sum of all the currents when each EMF acting independently. Okay, so I will read it once again. In a linear bilateral active network having more than one source of EMF, current flowing through any branch is sum of all the currents when each EMF act independently. For example, say consider the find current flowing through AB. Consider the circuits having resistances. So this is E1, say R1, R2, R3, this is E2. So the circuit is active, linear and bilateral. We have to find out the current flowing through this AB. Okay, this is the objective. Now there are three steps which we have to follow. Say the step 1. When E1 acting alone, in bracket, short circuit E2. Short circuit E2. Read all the diagram. Short circuited. And this is E1, this is A, B, R1, R2, R3. Say the current distribution is like this. Say current I, say here it is I1, here it is I2. Therefore here, as per the division of current, the I1 equal to, that is current flowing through AB, equal to total current multiplied by resistance through which current is not required, that is R2 divided by R2 plus R3 from A to B. Now the step 2. When E2 acting alone, we have to short circuit E1. Short circuit E1. Okay. So draw this diagram and short circuit E1. This is short circuited. This point is A, this point is B, this is R1, this is R2, this is R3, and our objective is to find the current flowing through R3, that is AB, when E2 is acting alone. Say this current is I dash. Say here it is I1 dash, and here it is say I2 dash. So once the total current is known to you, AB, that is I1 dash equal to I dash multiplied by the resistance through which current is not required, that is R1 divided by R1 plus R3. So this is the current from A to B. Okay. Therefore, step 3. When both E1 and E2 acting simultaneously, so when both are acting simultaneously, what is the current? Okay, so therefore current through R3, that is AB, is equal to I1 plus I1 dash. Okay, so I hope you understood it. Here, if there are 3 sources, you have to find out current flowing through the required resistance because of each EMF independently, and finally take their sum. So this is about the superposition theorem. So let's have an example based on this. Say, consider the simple circuit. Now from this, in this example, pay attention, it is asked to find out current flowing through, find current flowing through AB, that is 5 ohm, using superposition theorem, that is ST. Okay, so according to this, we have to apply the first step. say the currents are, you can estimate like this. Say the current is flowing, say this is I1 and say this is I2, and let us put the matrix form. So for the first loop, what is the R11? That is the sum of all the resistances through which current I1 is flowing. That is always positive. Then this diagonal element R22. So here it is 3 plus 5, 8, 8 plus 6, 14 plus 4, 18. So 3, 5, 8, 8 and 6, 14 and 4, 18. Okay. And R12 equal to R21. Here the current is flowing in opposite direction, therefore minus 4, minus 4. Here it is I1, here it is I2. Now the current I1 is entering into negative terminal of the battery first, therefore it is 100, and this current I2 is entering into negative terminal of the second battery, that is 50 volt source, and therefore it is also positive. So both are positive. Now see, let us start the step 1. When 100 volt acting alone and short circuit 50 volt, that is put equal to 0. Therefore this matrix becomes, this will remain as it is, 4 minus 6, then minus 4, 18, I1, I2, this is equal to 100 and 0, because you have to put 50 equal to 0. So find out which current we need the, see, current flowing through AB is I2, so we have to find out I2 equal to, now use calci and find out, see here, mode 1 equation, how many unknowns? 2, so A1 is 6 equal to B1 minus 4 equal to, then C1 100, then A2 minus 4 equal to B2 18 equal to 0 equal to, see, check it once again, 6 minus 4, 100 minus 4, 18, 0 equal to, this is I1, this is I2. I2 is 4.348 ampere. Answer is positive. Answer is positive indicates that it is flowing from A to B. Now the step 2. Step 2. When 50 volt acting alone, put V2 equal to 0, that is replace 100 by 0. So it becomes 6 minus 4 minus 4, 18 as it is, I1, I2, and this is 0 and 50. Find out I2. Six minus 4, 0, then minus 4, 18, 50 equal to, see, check it once again, 6 minus 4, 0, minus 4, 18, 50 equal to, this is X means I1 and this is I2, 3.26 ampere. So this is also from, as answer is positive, from A to B. So step 3. by using superposition theorem when both sources acting simultaneously. So therefore current I through AB, current flowing through AB equal to, this is 4.348 plus 4.348 plus 3.26, this is equal to this answer. So this answer is positive, and therefore it is also from dash from A to B. You have to come out from this mode, that is the equation mode, come to this 4.348 plus 3.26 equal to 7.608 ampere. So in this way we have obtained the current flowing through AB using the superposition theorem. You can verify your answer by using this Kirchhoff's law here also. See, from this also you can find out I2, and I2 is the current flowing through 5 ohm resistance. So let us check it. So 2 unknowns, A1 6 minus 4 got 100, then this is minus 4, and this is 18, this is 15, equal to 7.608 ampere. Okay, so answer is correct. Here also itself you can find out. You can check here. Check here, I2 equal to 7.608 ampere. Okay, that means here we have verified the answer by using the Kirchhoff's laws. By using the Kirchhoff's laws, we have verified the answers. So it's a very simple and tricky way to use the Kirchhoff's laws and to find the superposition, the solution by superposition theorem. I will stop here. Thank you very much.